Hi, and welcome to today's tutorial. We will talk about the new version of T3D version 1.10 and about the refractive materials that come with the updated Surface T3D. There are some other things that we want to cover, so let's get started. I will download the newest version of T3D and go to my downloads folder and drag and drop the T3D talks into my existing TouchDesigner project. It will disappear, but that's intended behavior. And there will be a toggle for T3D here in the upper right-hand corner. You will also find the T3D operator family in the upgrade dialog, and we're basically good to go. The first thing I want to talk about is where the T3D component actually lives, because it always disappears. And a few people have asked me about it. So what you can now do is you can right-click on the T3D toggle, go to the Advanced settings, and expose the main T3D component. And you will see that on the uppermost level of your TouchDesigner project, the T3D component is actually just hidden here. You can be curious and go inside and try to understand what I've done here, but you don't need to worry about it. I just wanted to mention this and show you that you can find the T3D component here, because this also makes it much easier to add it to your palette. So let's create a new folder in the My Components section of the palette. I call it T3D, and I will drag and drop the T3D component into it. So for future projects, I can just drag and drop T3D from the palette into my project. Okay, that's one thing I wanted to cover. Another thing that is new since T3D version 1.9, but I haven't talked about it yet, is the option to update old T3Ds. So I will go over here. This is an older project I have, and as you can see, it has T3D components from version 1.9. I will get these components and copy them over to my new network. As you can see, these are from T3D version 1.7, and the current version is version 1.10. Let's have a look at the sphere T3D from the most recent version, and the sphere T3D from the version 1.7. As we can see, there are some minor changes. Most importantly, there's a new uniform scale parameter that the old sphere T3D didn't have. So there would be a reason for me to update this. I wanted to give you the option to automatically update all old T3Ds without the need to delete them and then recreate them with the new ones. So now you can press update old T3Ds, and you will see that there's now on this older one the new the new parameter called uniform scale. And under the comment page, you will also see that the version is also updated to 1.10. And this is true for all T3Ds in this project now. I will actually undo this because I also wanted to show you that, well, these three T3D components, they are all from the older 1.7 edition of T3D. But let's say I only want to update, well, these two ones. Then you can also just drag and drop them onto the T3D. And now these two are updated to version 1.10, and this one is still at version 1.7. And last but not least, there are also these T3D stubs. That's a concept you probably don't have to care too much about, but that is mainly relevant for other creators using T3D in their projects and who want to share their project files with, for example, members of their Patreon. Of course, I wouldn't like them to share the whole T3D toolkit with their project file and not even the single components, because I would like you to get those from my Patreon. But if someone has built any kind of network using T3D operators, let's build a simple one here. I don't know, a sphere, a blur, and a transform. They don't do much, but just wanted to have an example network. And let's say I want to distribute this project now to people having access to T3D without distributing the T3D toolkit with it. So what I could now do is I can create stubs, and that will replace all the T3Ds in my network with T3D stubs, basically placeholders for their respective T3D components with nothing inside. I could then go ahead and remove T3D from the project, so there's no trace of T3D here anymore. I could then save this and distribute this file. That file can then be shared with anybody, and whoever has access to T3D can then again drag and drop T3D into their project, into this project they just opened. And as you see, T3D will regenerate all the respective T3D components together with all the parameters and connections that have been set. I hope this makes sense. I hope that you also don't really need to care about this too much, because most of this will happen behind the scenes. If you ever get a file by another creator that contains these T3D stubs, as soon as you drag and drop T3D into it, it will regenerate the original T3Ds. And if something doesn't work right away, you might want to go to the advanced page of the T3D settings and click Regenerate T3Ds yourself. Let's get into the fun stuff and have a look at the new Surface T3D. Surface T3D now has a few new parameter pages, most interestingly the refraction and the maps. We should start by creating some shape that we can plug into it. I will just use a torus for now. Let's use that as the first input to our surface that defines the surface. We can, as always, choose the surface threshold, and we should maybe right away go ahead to the torus and set its pixel format to be monochrome and 16 or 32-bit float. I will also increase the resolution a bit to 128 in all 3 dimensions, but that's fine for now. We could work with the build and rendering in here, but I want to go ahead and use my own rendering setup. So let's use a render top. This will, of course, look for a camera that isn't set up yet. We could use the default camera here, but I normally tend to go ahead and use either the camera viewport from the palette or the good old artboard camera that I saved myself here in my components. So I will work with that one. We can then connect an out top to the render top and maybe display this in the background. And well, everything is black, so let's bring in some light here. And there is our torus. I might want to shift the light to a more interesting position that is not straight up front. And you might see this, maybe not, but the resolution isn't too good. The rendering doesn't look too pleasing. On the one hand side, that is because the resolution of my rendering is quite low. So let's increase this to a reasonable value. I might want to set this to the resolution of my screen. So let's set this to monitors and then 0.width. That's a small hack. I don't know if you know this, but if you write monitors and then a number in square brackets behind it, you can get information about the monitors that are connected to your TouchDesigner project. So now this will always use the correct resolution for my screen here. I might also want to use some anti-aliasing after this, and now this rendering looks quite decent. Okay, let's get into the juicy stuff, the refraction steps. I can increase this to something bigger than 0, and you will see that suddenly we can kind of look through the torus. As long as this is at 0, you can basically think of the rendering process as rays being spawned at the camera and going through or towards the torus. They hit the surface and calculate the correct color there. If I increase the number of refraction steps, they won't stop there. They will then go into the surface, into the object that we have here, and be casted further until they hit the surface again. And the higher the refraction steps, the more often they will do this. Yeah, for a torus, this is only so interesting, but there's also more to explore here. On the one hand side, we can set the translucency. If I set this back to 0, it will look as if we didn't have any refraction steps. And now the higher the translucency, the further I can look through that object. Of course, this is now just white, which is maybe not exactly what we expected. There's not really anything behind my object, right? I would just cast those rays into the infinity. What we want to work with here is an environmental map. If you drop down a movie file in TouchDesigner and choose a file, you will be prompted to the samples of TouchDesigner and you will find an environmental map, either the cloudy ocean or the Palace of Fine Arts here. Let's go with the cloudy oceans. I will attach a null and call this env map. And now I could use this as the environmental map on the refraction parameter page of the surface. And now we can kind of look through the torus. And if I set the translucency to be really high, we can actually see that image there in the background. But this isn't really all that telling yet. So let's try to actually visualize the background as well. To that end, I will also add a new geometry to my scene. And I will call this BG for background. And what this is going to be is just one big sphere that is going to contain all of my scene. Be sure to turn the render and the display toggle on here. Oh, and also I should go to the detail page of that sphere and set the texture coordinate to be equirectangular inside, not outside. Now I can use a constant as the material for that sphere and the environmental map as the color map of the constant material. Now you see that the environmental map is mapped onto that sphere. And if we now make that sphere big enough, like really big, you will see that I can now look around in that environmental map. Very good. And as you can see, I can look through that torus and into the environment behind my torus. So this is basically rather what happens if you set the translucency to be. The higher the translucency, the more of the background you can basically see. Next up is the refraction index. This defines how light is being bended by your geometry. So if I set this to something other than 1, you will see that the light is now really refracted, similar to a glass-like material. And you might want to keep this close to 1, so either something slightly above 1 or slightly below 1 to have it look realistic, but you can of course go crazy and explore the looks of it with different refraction indexes. Okay, let's set this to 0.95. I think that's reasonable. Cool. This already looks quite a lot like some glassy surface. There's also an occlusion strength parameter. Let's use a value higher than 0 here, and it turns slightly black. Well, that is because the occlusion color is black. Let's use something else. Let's use some kind of orange. And now with that occlusion parameter, we can tint the material. Let's have a look at it. So this now looks a little bit like tinted glass. Okay. I'm a little bit bored by the torus that we're working with here, so we can either make it thicker or let's go with a whole new shape. I will just use some noise. Or I will first use a noise. So again, I will set this to be 32-bit float, and I will set the resolution to 128. And let's connect that as an input to our surface. I might want to increase the period a bit because this is too detailed and reduce the harmonics. And now I can look around and see a little bit that shape. The shape looks strange where the shape intersects with the border of the T3D, so where the box hits the surface, I would say. That is because the normals can't really be calculated correctly at that point. One way to work around that is to use a blur and just give it a couple of blur passes. Now that looks more decent. And I think this already looks quite interesting. Cool. We can, of course, animate this if we want to. let's write down me.time.seconds times some small number here. And now we have an animated glass thingy floating in space. And I do think this already looks quite interesting. Of course, we haven't touched the material, the regular material parameters here yet. So as long as we're talking about Phong materials, we can, of course, work with the shininess of the material. I personally don't find Phong materials too interesting most of the time. You can also set the specular and the diffuse and everything. But let's have a look at PBR material. The cool stuff with PBR material is that this also supports those environmental maps. So we can actually use an environmental light as a new light source and also connect the environmental map as the environmental map of our PBR. And that will, if we now tune the parameters correctly, can look quite nice. So now that I've set the material type of my surface to PBR, I can set the roughness and metallicness of my material however I want. For instance, this might be quite interesting. And well, this is actually for you to explore. I hope you find some interesting looks with all of this. But one thing I definitely wanted to show you is that with the new Surface T3D, there's, beside all this, also a new maps page. Because it was Polyhop. Thanks a lot. Thanks a lot, and shout out to Polyhop, who brought up the idea of controlling these material parameters locally using other T3Ds. So now there's an option to use maps on Surface T3D. And if I turn this on, you will see that there are now more than 2, actually a total of 7 inputs to my Surface T3D, which allow me to control these parameters locally. As an example, I could bring up a box T3D, and I will maybe scale it down in vertical, in Y, and use that as an input to the translucency. And maybe I should increase the overall size of it a bit and then decrease that again. And now you can see how this material is translucent. Let me go to the refraction page of the surface and set the overall translucency quite close to 1. Now you can see how if my refraction index is something close to 1, I can basically look through the material in the middle of it, especially if I reduce that occlusion strength. So I can now look through the material in the middle, but at the bottom and the top, my material isn't look through, but there it's really metallic. Okay, so now I can locally control how that looks like. I can decrease that size, and of course you can come up with any shape for those materials. I could also use a noise here again, and maybe this shouldn't be too high in detail either. Maybe use some low exponent, and then of course that should also be 32-bit float because this defines my a single value and no color. This now looks a little bit strange, and that is because this goes above 1 and below 0. So we might want to connect another limit T3D and clamp that value between 0 and 1. And now we have basically different values for our material at different positions of our shape. Okay, I hope you get the idea. And now I'm currently using this for the translucency, but you can input this now to ambient, roughness, metallic, and specular if you're working with PBR. But if I would work with Phong, you can instead input to translucency, shininess, emit, specular, and diffuse. Yes. That's basically what you have here. And I could put that into, I don't know, roughness as well. And then we would see really different materials at different positions of our object here. I'm looking forward to seeing you all getting creative with this. One thing I should mention is that you can set these maps to either be used as a multiplication or to just set the value. In general, I would recommend to set this to multiply. If you set this to set, then you would probably want to define all 5 additional map inputs with something and leave none of them as their default, because they default to a value of 1. Okay. So far, so good about maps. Last thing I want to mention here is the buffers. So I will reduce the number of refractions a little bit, because this is also, as you can see, eventually going to be quite tough on your GPU. So the more refraction steps I take, the more expensive this calculation gets. So if I'm at 6 refraction steps, I'm only at 40 FPS. I'm on my laptop here, but still be aware of how performative this can get and don't burn your GPU. But I got distracted. I just wanted to mention those color buffers. Similarly to the regular PBR materials and so on, they have an advanced parameter page where you can set multiple output buffers and choose what information to actually output to those buffers. And the same now goes for the Surface T3D, where you can now attach multiple output buffers, and you can choose to either show the full shading, you can output the world space position. So this now encodes in red, green, and blue the X, Y, Z position of each point on the surface. You can also choose to output the T3D UVW. So this is similar to a UV position, but 3-dimensional. You can output the world space normal. And you can also output the T3D normal. So the world space normal, this would change with rotation and scaling and stuff of the overall geometry, while the T3D normal will be local, and then you would rotate the normal kind of with the geometry. Okay, so this is not really, well, this might look cool, but it's not really intended to be visually used, although it really does look cool, but it's rather something that you could use for post-processing effects and so on. Yeah, and as I said, you can have multiple of those, so I could output both the full shading, but maybe I'm also interested in the world space positions. And then I could use a render select together with my render top, where I would need to go to my render top and set the number of output color buffers to 2. And then I could go to my render select and select index 1 here, and then I now get the full shading in the first buffer and the world space position in the second one. Okay, I think this is about it. I hope you like what I've created here for you, and I'm looking forward to seeing what you explore.